All right, looking at similarity in triangles. So here's our definition for similarity. Two polygons are similar if corresponding angles are congruent and corresponding side lengths are proportional. So we'll specifically talk about triangles in this. So here are two triangles that you can draw. A, B, C, D, E, F are two triangles. So if our corresponding angles are congruent, like A and D are congruent, B and E are congruent, C and F are congruent, and then the corresponding side lengths are proportional. So if we say that triangle ABC is similar to, that's what that symbol means, triangle DEF, then we would know the following things about it, right? We would know that angle A is congruent to angle D, which we have in our picture now. Angle B and angle E are congruent, and angle C and angle F are congruent. We also know that corresponding sides are proportional, right? There's a ratio that would be proportional. So we would say segment, the length of AB over the length of DE is equal to the length of BC over EF. So notice how we did the first two, the last two, the last two. So then we do the first and the last and the first and the last. So here is our definition of similarity. If we know all of this or some of this, it helps us to prove that two triangles are similar. So there are a couple of things to know about similar triangles. So first of all, there is the idea of a scale factor. So if two polygons are similar, then the ratio of the lengths of two corresponding sides is called the scale factor. So we can write that down, but here's an example for us to help figure out what our scale factor is. So in our diagram below, we can see these two triangles that are similar, and we want to find our scale factor. So it already tells us they're similar, so we can use it to help us. So we know that that just like before, we can compare the first two with the first two on this side. So how we'll set up our proportion, we'll have RS over XY so I just took the first two over the first two, the last two over the last two, and then the first and last over the first and last. So now let's figure out what we know. So do we know what RS is? Well, that would be 8. So I'm going to just fill this in underneath for what I do know. So I know RS is 8. I know XY is 16. ST is 6, and YZ I don't know, but I can leave that. And then RT is 7, and XZ I don't know. All right, that 7 is looking close to a Z, but this is a 7 right here. So we can figure out our scale factor by just figuring out, what does it say? The ratio of the lengths of two corresponding sides. So two corresponding sides, like these two, these are corresponding sides together. The ratio we had was 8 over 16, but we can simplify that to 1 to 2, or 1 over 2. So our scale factor is 1 over 2. So that's telling us that this triangle here is twice as large as this triangle here. All right, then the second part says find YZ. Well, I set up a proportion right here, so I could actually just solve this. Before we solve it though, make sure that you simplify anything that you can. So notice how here I could simplify this, and then I would just solve that first part. So yz equals 6 times 2, so yz equals 12. And then we answer our question. Remember how when we are talking about the length of a segment, we don't include any symbols above it. So then there are 3 different ways to prove that triangles are similar. The first way is angle-angle. So if we look at this question we have here, we're given 2 angles for each of the triangles. Remember that the interior angles of a triangle always have to add up to equal 180. So if we figure out the third angle of each of these, then we could figure out if our triangles are similar. So if we have those 2 side lengths, we solve, and angle B, we actually get 60 degrees. 60 degrees. And then for angle M, we solve, we get 50 degrees. So we actually know that all the angles are congruent, but we only needed to know 2 of them. So because of that, we can say that they are similar by angle-angle. So our similarity statement we're going to write is comparing the 2 triangles. So if I started, triangle ABC is similar to what triangle? So think of A. A was 50, so that would have to go with M. B was 60, so that has to go with N. And then C was 70, so that has to go with P. So similar to triangle M and P. 5. By angle-angle similarity. So that's how we would write our answer for that. Alright, so another way we prove that they're similar is by side angle side. So right here, notice how we have 2 sides of this triangle, and we have 2 sides of this triangle. So we're trying to figure out if the included angle is also congruent, which we know that it is because it's they're vertical angles. So those 2 are congruent by vertical angles, and now we have to compare our side lengths. So we always do our small and our big together. We compare the 2. So the small side of this triangle is 10. So 10 over the small side of the other triangle is 15. And I'm trying to figure out if those are proportional with the other triangle, or with the larger sides. So 10 over 12, or 10 over 15, does that equal 12 over 18? So let's reduce. 10 and 15 are both divisible by 5, so I get 2 over 3. 12 and 18 are both divisible by 6, so I get 2 and 3. So our scale factor then would be 2/3, and and that proves that they are similar. So I can say triangle PAE is similar. And now let's think of what triangle, or what point P goes with. So P was with the non-included side and the small leg. So the non-side and the small leg would be N. And then we went to A, which would be on the outside here, and then to the E. So N to E. Triangle 5. And these are similar by side angle side similarity. Good. So the last one is side, side, side. So if all of our sides are proportional, then they're similar. So how I'll set this one up is I'll even just underline my smallest side. And then I'll put a circle around my biggest side. Because that helps me to remember how I'm gonna set up my proportion. So I always go small over small. So I'll go 4 over 8. And I'm trying to see, does that equal the medium over the medium? And does that equal the large over the large? So 6 over 12. So when I reduce these, I notice that I get 1 over 2 equals 1 over 2 equals 1 over 2. So these are similar because I get the same scale factor for all of them. So I can say triangle ABC is similar to, and notice how I started between these two symbols. So I'm going to start with Y, and then I went through the smaller side. So Y, X, Z. By side, side, side similarity. Cool. I hope this was a helpful refresher for you, and we'll have another video talking more in depth about these concepts. Thanks.